gentlemen, today we're going to talk about decay. We're going to write and graph exponential decay functions. Okay, I'm going to read the vocabulary. When a is greater than 0 and b is less than 1, the function y equals ab to the x represents exponential decay. The graph of an exponential decay function falls from left to right. In comparison, the graph of exponential growth function rises from right to left. Okay, so this is exactly the same thing we talked about yesterday. Instead, the only difference is it's y equals a b to the x, where b is whatever it is minus 1. Okay? So we're talking about decay. So instead of adding 1 to it, we have 1 minus that. Okay? And it's written up here on the board in blue as well. Alright, so the first thing we're going to start with, ladies and gentlemen, is we've got this lovely table, and we are going to make a function from it. Okay? So we've done this before. There's an example on the whiteboard over here. We're going to put it in y equals ab to the x. Okay, to find b, the first thing we're going to do is plug in when x equals 0, what is y? Y is 1/3. We get equals a b to the 0 power. B to the 0 power is what? Anything to the 0 power is 1. So we get 1/3 equals a, right? Because anything times 1 is itself. Rakisha, can you get out a pen or pencil and start doing this, please? What? You don't know how to copy down from the board what I'm writing?
I was supposed to copy down that.
Well, then you can ask a question, but you need to sit up and do this now. Then you need to go to the office, Rakisha. That's your choice. Would you walk her down to the office? Okay. So, ladies and gentlemen, we found out what A is. Now we're going to find out what B is. So we get y equals 1/3 b to the x. In order to find out b, we're going to plug in what 1 is for x. Y is 1 when x is 1. Okay, so we've got to figure out what times b gives me 1. We've got 1/3 times what gives me 1. So I'm going to multiply by the reciprocal on both sides, 3 over 1 times both sides. And I get 3 equals b. So now I'm finished. I just have to rewrite my function. Y equals 1/3 times 3 to the x. That is our final answer. Okay? All right. Let's turn our paper over, and we're going to graph a few functions. Okay, so the first thing we're going to graph, ladies and gentlemen, is y equals 1/2 to the x. So we're going to make our table. -1, 0, 1, and 2. Okay? We know that 1/2 to the -1 is what, Christian? Anything to the -1 power means we do what to it? Flip it. So my answer is going to be positive 2 to the 1/2. Christian, what's what? Christian, not Christian. CJ, 1/2 to the 0 power is 1. Jen, what's 1/2 to the first power? 1/2. Yusuf, what's 1/2 squared? 1 over 4, thank you. Okay, so we put our first dot. We go to x -1, we go up 2. Then we go to x is 0, up 1. Then we go to x is 1, up 1/2. And then we go to x is 2, and we go up 1/4. Okay? My my domain is all real numbers, and my range is y has to be greater than 0. But we can see that it starts up higher on the left and goes down when we get towards the right. So we know that's decay. Okay. So the next one, I'm going to graph the same, on the same graph paper, two different equations. The first one I'm going to do is y equals 3 times 1/2 to the x. And the next one is y equals negative 1/3 times 1/2 to the x. Okay, so I'm going to make a chart again. X and y, I'm going to put the same numbers, negative 1, 0, 1, and 2.
Is that a 2 or
X with y. 1/2. Okay, so we've got 3 times 1/2 to the negative 1. That means we flip over my 1/2 and I get 3 times 2, which gives me 6. 3 times 1/2 to the 0. Kirsten, what's 1/2 to the 0 power? 3 times 1 is 3. Okay. Shelby, 3 times 1/2 to the first power. What's 1/2 to the first power, first of all? Okay, so now we've got to go 3 over 1 times 1 over 2. What are you going to get? 3 times 1 is? 1 times 2 is? So it's 3 halves or 1 1/2. And then we're going to go 3 times 2 to the 1/2 squared. Brett, what is 1/2 squared? 1 times 1 is 1 over 4. And so we multiply that by 3 and we get 3/4. Okay, so we go to negative 1 and we go up 6. We go to 0, we go up 3. We go to 1, we go 1 1/2. We go to 2 and we go to 3/4. Okay, now the next one I am going to do in green because we are comparing them. So we're going to put them on the same graph. Alright, Cheyenne, what is, we've got y equals negative 1/3 times 1/2 to the x. What is 1/2 to the negative 1? Two over 1, and 2 over 1 times negative 1/3 is negative 2/3. Joel, what is 1/2 to the 0 power? 1. And 1 times negative 1/3 is negative 1/3. Terrence, what is 1/2 to the first power? 1/2 to the first power is 1/2. 1/2 times negative 1/3 is negative 1/6. Tabitha, what is 1/2 squared? 1/4. 1/4 times negative 1/3 is negative 1/12. And then we graph it. We've got negative 1, negative 2/3, 0, negative 1/3, 1 is 1/6, and 2 is 1/12. Okay? We can see the difference between these and my first one. The y equals 1/2 to the x does not go up as high as 3 times 1/2 to the x. And when we multiply it by a negative, we know it flips it over our x-axis. Okay, and it's 1/3, so it's much closer to the x-axis than either of our other two. Okay, let's turn it over, please. Okay, this first graph, is it growth or decay? Elena, is this second graph growth or decay? as it's going down. All right, let's go ahead and look at our story problem. Okay, our story problem says you bought a car for $16,000. You expect the car to lose a value depreciated at 12% per year. Write an exponential decay model to represent this situation, then use the model to find the value of the car after 8 years. So, Aaron, what is the starting value of the car? Aaron Johnson. Aaron, what is the starting value of the car? $16,000. So if I'm putting it in y equals a b to the x, that becomes my a. Okay. So Haley, what is the rate? 12%. And remember, we're doing minus this time. So we're going to go 1 minus 0.12. Okay? If we're making a model now, we just put it to the x. But they want us to know what this is after how many years? Erica? 8. Okay, so now you should just be able to put this in your calculator. You're going to take out your calculator. You're going to type 16,000 parentheses 1 minus 0.12. Hit the caret button, which is right under the pi button, to the 8, and you get, after 8 years, your car is worth only $5,754.15. So the big difference that we talked about today from yesterday is instead of adding a 1, you go 1 minus whatever your percent is.